I am presenting a question about inequalities. We're given that x is greater than y, and z is less than 0. The challenge is to figure out which inequalities must always be true using these facts. To solve this problem, I need to use the rules for working with inequalities. I especially have to pay attention to what happens when you multiply or divide by a negative number. The inequality sign flips. This is the core question. We are given that x is greater than y and that z is a negative number. Google style name assertive. Let's carefully consider the impact of these conditions on each potential inequality. Google style. If I add the same negative number, z, to both sides of the inequality xy, the inequality remains the same. Therefore, this inequality must be true. Subtracting z from both sides of xy is the same as adding z. Similar to the previous one, subtracting a negative number from both sides will not affect the direction of the inequality. Since z is negative, multiplying both sides of xy by z flips the inequality sign. This results in xz being less than y. Dividing both sides of xy by z, which is negative, also flips the inequality sign, leading to xz y. Let's explore this inequality. We know that x is greater than y, and z is a negative number. When you multiply both sides of an inequality by a negative number, the inequality sign flips. So, because z is negative, multiplying xy by z gives us xz y. Break time 300 milliseconds. Pretty cool. Huh? I'll show you why this inequality always holds true. We are given that xy. If I add the same number z to both sides of that inequality, the inequality remains unchanged. Thus, xz. It's simple addition. Break time 300 milliseconds. See? No magic involved. Here's another one where the negative number z plays a crucial role. Remember, when you divide both sides of an inequality by a negative number, you have to flip the inequality sign. Since z is negative, dividing xy by z gives us xz y. Break time 300 milliseconds. This inequality correctly reflects the sign change. This one's straightforward. We start with xy. Subtracting the same number z from both sides doesn't change the direction of the inequality. Therefore, x, z, y, z is always true. Break time 300 milliseconds. That's basic subtraction. Easy peasy. Let's dive into this inequality challenge. We'll explore how to manipulate inequalities, especially when dealing with negative numbers. Break time 300 milliseconds. Get ready to sharpen your inequality skills. Break time 300 milliseconds. We're given that x is greater than y, and z is a negative number. Break time 300 milliseconds. These are the crucial facts well used to test each option. Google style name lively. Remember these conditions. Google style. Our job is to figure out which inequalities are always true given the information we have about x, y, and z. Break time 300 milliseconds. Let's examine each option carefully. I'll consider the inequality xy. Since z is negative, when I multiply both sides by z, I must reverse the inequality sign. That's the key rule here. The result is xz y. So option A is correct. I'll consider the inequality xy. Adding the same number z to both sides doesn't change the direction of the inequality. The result remains xzyz. Therefore, option B is true. Similar to option B, subtracting z from both sides of xy also leaves the inequality unchanged. This leads to x, z, y, z, making option D correct. I start again with xy. When you divide both sides by a negative number z, you must flip the inequality symbol. So xz y. That makes option C also correct. Let's explore which inequalities always hold true when x is greater than y and z is a negative number. Well, test each option individually. Google style name conversational. This is like a detective puzzle for inequalities. Google style. I'll start with this one. Since z is negative, multiplying both sides of xy by z flips the inequality sign. Google style name emphasis. Think of it like this. Google style multiplying by a negative number is like looking at a number line in a mirror. It reverses everything. This gives us xz years. So A is true. Adding the same negative number z to both sides of xy doesn't change the inequality's direction. Google style name explanatory. It's like adding the same weight to both sides of a balanced scale. It stays balanced, and the heavier side is still heavier. Google style thus. xz/yz remains true. Therefore, B is true. Dividing both sides of xy by a negative number z also flips the inequality. Google style name excited. It's the same mirror effect as multiplication. Google style this means xz years. So, C is correct. Subtracting z from both sides of xy keeps the inequality pointing in the same direction. Google style name conversational. Subtracting is like taking the same thing away from both sides of a balanced scale, leaving it still balanced. Google style this gives us x, z, y, z. D is also true. This question asks us to determine which inequalities always hold true given that x is greater than y and z is negative. Well, need to carefully consider how multiplying and dividing by a negative number affects the inequality. Break time 300 milliseconds. Let's explore each option to see which ones are always true. Google style name lively. It's a bit of a detective game. Google style. Let's see. If x is bigger than y, and I multiply both by a negative number z, the inequality flips. So, yes, xz will indeed be less than y's. Break time 300 milliseconds. For example, if x2, y1 and z-1, then 2, 1, 1, 1, which simplifies to -2 -1. That is true. Adding the same number to both sides of an inequality doesn't change the direction. Therefore, if xy, then adding z to both sides gives me xz/yz. Break time 300 milliseconds. This one always holds true. Think of it like adding a weight to both sides of a balanced scale. The heavier side will still be heavier. When you divide both sides of an inequality by a negative number, you must flip the sign. Because z is negative, I flip the inequality. Therefore, if xy, then xz years. This works since x1 y1 becomes xy. If x2 and y1, then -2 -1. Which is true. Subtracting the same number from both sides of an inequality keeps the inequality the same. So if xy, then subtracting z from both sides gives me x, z, y, z. Break time 300 milliseconds. It's like removing the same amount from both sides of a balanced scale. The heavier side remains heavier. This problem asks you to determine which inequalities always hold true when x is greater than y and z is a negative number. We will test each option to see if it is always true under these conditions. Break time 300 milliseconds. I'll guide you through each step. Let's examine option A. Google style name emphasis xz lieutenant yz. Google style. We know x gty and z lieutenant 0. If I multiply both sides of x gty by a negative number z, I must reverse the inequality sign. Break time 300 milliseconds. That's a key rule for inequalities. So, I get xz lieutenant years. Therefore, this option is correct. Now let's look at option B, Google style name emphasis XZGTYZ Google style. If I add Z to both sides of the inequality XGTY, the inequality sign remains unchanged. The inequality holds true. Therefore, this option is correct as well. Break time 100 milliseconds. Adding or subtracting the same number from both sides of an inequality doesn't change its direction. Next up, option C, Google style name emphasis XZ Lieutenant YZ Google style. Since Z is negative, when I divide both sides of XGTY by Z, I must reverse the inequality sign. This results in XZ Lieutenant YZ. Break time 200 milliseconds. Therefore, option C is correct. Finally, option D, Google style name emphasis X ZGTY Z Google style. Subtracting Z from both sides of XGTY doesn't change the direction of the inequality. Break time 150 milliseconds. It's always true in this case because subtracting the same number from both sides maintains the inequality. Hence, option D is also correct. I found all options A, B, C, and D to be correct based on the rules of manipulating inequalities involving negative numbers, which we just discussed. Break time 300 milliseconds. Pretty neat. Let's dive into this inequality challenge. We'll explore how to solve these types of problems. Break time 300 milliseconds. Get ready to master inequalities. Okay, we're given two key facts: X is greater than Y, and Z is a negative number. Break time 300 milliseconds. These facts are crucial for figuring out which inequalities must be true. Our mission is to determine which of the following options are always true. Given what we know about X, Y, and Z, break time 300 ms. Let's analyze each choice carefully. Let's break this down. Because Z is negative, when I multiply both sides of XGTY by Z, I must flip the inequality sign. So, yes, XZ is less than YZ. Here, I am adding Z to both sides of XGTY. Adding or subtracting the same value from both sides of an inequality doesn't change the direction of the inequality sign. Therefore, this is always true. This is similar to part A. Since I am dividing both sides by a negative number Z, I must flip the inequality sign. Therefore, XZ is less than YZ. Subtracting Z from both sides of XGTY doesn't change the inequality. This one is straightforward and always true.